Now, chemistry live class is starting. Thanks for waiting patiently.
Today topic, same topic we are going to follow as well. Haloalkanes and arenes. In that previously just we have completed about naming and also the preparation and physical properties. And today just we are going to see about the chemical properties of haloalkanes alone. That is chemical properties. Okay. So first of all, we know what is haloalkanes. Generally, if you take any alkanes, okay, any alkanes, CH4, in that CH4 alkane, first member, okay, just replacing one hydrogen by any halide group. We know that the halide group is we can take a chlorine, bromine, iodine, and this fluorine. So if just by replacing one hydrogen by a chlorine, okay, we'll get a haloalkane. General name is haloalkane, but specifically we can say this name is methyl chloride. Okay, the name of the alkyl group is methyl and followed by a halide name is chloride. So this is a general haloalkanes. By taking an example, if I take methane, replacing one hydrogen by a one chlorine, or you can take a ethane, propane, subsequent hydrocarbon we can take, and you can replace one of the hydrogen by any halide group. You will get a haloalkanes. Generally, this haloalkanes I can write or X. We know that or it can be any type of alkane group. X can be any type of a halogen. You can take chlorine, fluorine, bromine, or iodine. So this, okay, X can be any type of a halide. Okay. Now we are going to discuss the chemical properties based on the reactivity of a alkyl group, that is haloalkyl group, based on reactivity. Okay. Now, generally, haloalkanes are more reactive. Okay. Why does haloalkanes more reactive? If you take this RX, okay, RX. So it is understood whatever may be that halide group. For example, if I am taking the CH3Cl, C, H, 3, single bond, C. Okay. Now it is understood how the bond is formed. Just I am drawing a single bond. Isn't it okay? Single bond. So how the bond is formed, we know. The bond it is a single bond. So the bond can be formed by the sharing of electrons between the two atoms. Okay, between the two atoms. So here the carbon is 1 and chlorine is 1. Okay. So if you are comparing, carbon is positive nature. Okay. And this chlorine is electronegative in nature. Electronegative in nature. Okay. So now what happened? So here the chlorine is more because of this more electronegativity. Okay. So what is called So what is called the electronegativity means the tendency of an atom, whatever that is, especially with the halogen groups, the tendency of this atom, okay, to attract the shared pair of electron towards itself. This is called the electronegativity. That is tendency to attract, okay, shared pair of electron. Shared pair of electrons. Okay, now if you take the bond between the carbon and the chlorine, okay, the bond is the carbon has to give 1 electron. Okay, isn't it? The chlorine has to give 1 electron. Okay, the carbon gives 1 electron and the chlorine gives 1 electron. So by using of these 2 electron only, the bond will be formed between this C and the Cl. So then only we can expect the CCl bond. Okay, we are not talking about here hydrogen bond. How the bond is formed between carbon and hydrogen? We know that the carbon has to form 3 single bond with the hydrogen. So here no problem. Between carbon and the chlorine. Okay, here the bond is formed between carbon gives 1 electron and chlorine gives 1 electron. Isn't it okay? Okay. Now, because of the more electronegativity nature of chlorine. Okay, now what happens? The tendency of attracting. This is called the shared pair of electron. Why shared pair of electron? Because we are giving the atom has to donate the electron, okay, for the formation of a bond. So then only we can call it as this is called a shared pair of electron. Okay. So because of more electronegativity nature, the chlorine wants to pull the electron towards. Okay, pull the shared pair of electron towards it. Then what happened here? Okay, so almost the chlorine has gained 1 electron pair. So in the same way, the carbon has lost its own electron. So now what happened? Because of this, carbon has lost own electron. It's getting positive sign. Okay. And next, okay. So here, the positive sign you can write as del plus because this is a partial, okay, partial charge separation. I can write del plus, okay. And next, okay, the bond is not cleared properly, and Cl, I can write del minus. Del minus, okay. So this is called that is polarity. So simply, what is called polarity means charge separation. Simply, we can call it as polarity means charge separation. Okay. If you take any system, okay, whenever if you find that a more electronegative element, the more electronegative element, what happens? Start to pull the electrons from the shadow, from the bond formation. Those electrons pulled by the more electronegative element, and it takes almost all the electron towards it and thereby getting a negative sign. This is called a polarity. Okay. Now, before itself, I'll tell you one point about the reactivity. the reactivity is due to the presence of a polarity. Okay, the polarity makes the molecule becomes more reactive. Okay, so that's why haloalkanes are more reactive. So, due to the presence of what? Polarity. So, what is the meaning of polarity? Charge separation. Okay, so then it is clear about the reactivity nature. Now, this reactivity nature only makes a haloalkane to involve in many type of a reaction, because of course, what is chemical property? How this the substance, whatever may be the organic compound, how it is going to be involved with the other substance, how it is going to be combined with the other compound only called a chemical property. Here we are going to discuss the chemical properties based on the reactivity only haloalkanes. Okay, so next we are going to discuss. Okay, we are going to discuss about the chemical property based on the 4 types. Okay, based on types. One is nucleophilic substitution. Okay, so first one, nucleophilic substitution. Okay, and second one we are going to discuss about elimination reaction. Elimination reaction. Okay, and third we are going to discuss about reaction with metals. Reaction with metals. Okay, and fourth one, reduction. Okay, we are going to discuss the chemical properties of haloalkane in what times? 4 days. The 4 reactions we are going to do. Okay, deal with the 4 reactions. Okay, now first we can start with the nucleophilic substitution. Okay, before entering into nucleophilic substitution, we should know what is nucleophile. Okay, what is called a nucleophile? The nucleophile is nothing but carries a negative sign. Any species carries a negative sign. Okay, species with the negative charge. Negative charge. Okay, I'll give you an example. The nucleophile, there are 2 types of a nucleophile. One is a negative nucleophile. Okay, and next one is a neutral nucleophile. Okay, what is the first one? Negative nucleophile, neutral nucleophile. So, just an example for a negative nucleophile. You take Cl minus, chloride ion, Br minus, bromide ion, fluoride ion, iodide ion, cyanide ion, nitrite ion. Okay, so first one is chloride ion, bromide ion, fluoride ion, iodide ion. This is cyanide ion. Cyanide ion. So carries negative charge only. So we should end with the ion. Okay, so don't say cyanide ion. This is nitrite. We know nitrate also possible. This is nitrite. NO2 minus. Okay, so this is an example for a negative nucleophile. Negative nucleophile means carries a negative charge in it. Okay, so it talks about the electrons. So if you take neutral, okay, so neutral, let me take water. Okay, and ammonia. This is ammonia. Okay, ammonia. If you take amine, simple I have given RNH2, this terms of a amine. Okay, so you can ask this you say that negative sign is there, so we understood this is a nucleophile because as per your definition, species with a negative charge told. But if you take a neutral nucleophile, students you can ask, okay, why your without negative charge you are given this is a nucleophile. Here also one more point you have to remember. So in that molecule water, so let me take water is made up of what? Hydrogen and oxygen. Here oxygen is more electronegative element. Oxygen carries two lone pairs of electron. Okay, so this lone pairs of electron acting as a negative charge. Same way in ammonia, nitrogen carries one lone pair of electron. Same way in primary amine also nitrogen is there, so carries one lone pair of electron. Again, one more doubt comes to your mind. This your left hydrogen. For oxygen only, you told me two lone pair of electron. How this possible? So on what base we can select which atom as nucleophile means those atoms carries more electronegative nature in the periodic table. We know that already more electronegative element. That property mainly assumed to nitrogen, fluorine, chlorine, bromine, iodine, oxygen only. Those element, okay, those element, if you find that present in the compound, definitely it should have what character? That is a bond character. Okay, so lone pair of electron almost available on the particular atom. So this is called a lone pair. Okay, one more. Just I am introduced a new word. What is called a lone pair? So we know that the electron which is involved in the bond formation. So bond formation, for bond formation, those electrons which is involved in the bond formation, we can name it as bond pair. Because we don't know what is called bond pair, and frequently if I use lone pair means we don't know. That's why I'm giving. So bond formation, electrons involved. Okay, the electrons is involved in the bond formation. Then we can say this is called a bond pair. Okay, the electron which is, because we know that not all the electrons are participating in the bond formation. Because if you want to construct a single bond, only the one electron we need for the bond formation. Okay, so one atom has to give one electron, another atom gives another electron. So what about the remaining? So the remaining those electrons acting as a lone pair depending upon the compound. Okay, depending upon the compound. And those electrons only we can name it as a lone pair. So what is called a lone pair? The electrons not involved. Okay, not involved in bond formation. Okay. So I think I have cleared about bond pair and the lone pair. Because the bond pair means we are talking about single bond and double bond, and how many electrons involved. Okay. Lone pair means the electron which is not involved in the bond formation. Okay. So now we know about what is the concept nucleophile. So nucleophile means what? A species with the negative charge. Okay, species with the negative charge, and those can be what possible. And two types. One is negative nucleophile, and another one is a neutral nucleophile. Negative nucleophile clearly shows negative electron which is placed on the power of individual atom. But neutral, it is not possible to predict. But based on the more electronegativity, those electronegative element only carries a lone pair of electrons. Okay. So I am clear with the nucleophile. Okay. So let us know what is called a nucleophilic substitution. Where the nucleophile is going to attack. we know about the polarization of the haloalkanes. Generally, if I am taking carbon, okay, so carbon and Cl, we assumed this is a positive character, this is a negative character. Okay, now if I add a nucleophile shortly, the symbol for nucleophile is Nu negative, nucleophile. Okay, so if you add any in the polar molecule, if you add a nucleophile, the nucleophile where it is going to attach. Okay, that is one more question. So nucleophile is what nature? What nature? It is a negative nature. Okay. So always negative part will go and attack the positive center. The positive center is nothing but electron deficient center. So as del plus, we can call it as this is sometimes they may give electron deficient. Okay, so electron deficient center. So the nucleophile attacks the electron deficient center. Okay, here only the nucleophile is going to attack this. Okay, and positive charge will be neutralized, and the Cl getting S. Okay, so if I indicate also just I am indicating one carbon with a Cl. Okay, for example, if I am taking instead of this methyl chloride, okay, the haloalkane methyl chloride. Now what happened? Here CH3 will be present. Okay, you should assume that I can replace CH3 or CH3 CH2 methyl, ethyl, propyl because the group is like this. This is a methyl group. This is a ethyl group. Like this. This is an alkyl group. Okay. CH3, CH2, CH2. This is propyl. Because why I am indicating N? Because this is a straight chain compound. This is straight chain nature. For that only indication N. N represents straight chain. And this is your ethyl. And this is your methyl. We know already this is a type of alkyl group. So one is methyl, one is ethyl, and N-propyl. You can replace whatever may be the alkyl group. Then you will, according to that, you are going to get a product. Okay. So this is your how this nucleophile is attacked the electron deficient center. Okay. Now, can you understand about how the nucleophile and where the nucleophile is going to attack? Okay. Now we can see some of the reactions based on the nucleophilic substitution. Okay. So here we are going to talk about nucleo. So far we discussed about what is nucleophile, how the nucleophile will be attacked like that. Now we are going to discuss about nucleophilic substitution. Students, already we know what is the meaning for substitution. Substitution means one should be substituted by another. One should be substituted by another. So here, what I am going to substitute? So you can ask nucleophilic substitution. So by the word itself, we can take one nucleophile. Okay, one nucleophile will be substituted. Okay, one nucleophile will be substituted by another nucleophile. Okay, so it is understood. I'm going to replace, okay, one nucleophile by another nucleophile. Then only we can call it as this is nucleophilic substitution. Okay. So based upon the reactivity only we can replace. Okay, now let us see one by one the reactions. Okay. So first reaction. Reaction with the KOH. We know what is KOH? Potassium hydroxide. Okay. So potassium and sodium are both equivalent elements. We can take sodium also, no problem. So a reaction with the potassium hydroxide. Okay. Now what property we are seeing today? Haloalkanes. So what reactant I have to take? The haloalkane. So what haloalkane let me take? So we can take any one haloalkane. We can change whatever we want. Suppose, for example, I'm going to take the haloalkane CH3 CH2 Br. Okay, we know that CH3 CH2 is a ethyl group. Br is a bromide. So now what is the name? That is ethyl bromide. So ethyl bromide is whether it is common name or aliphatic name, because already we know about how to give the name. Okay. Ethyl bromide is a common name. Shortly I will give you CN, common name. Okay. So what is the aliphatic name? Bromo, because it is start with the alkyl, first halide group followed by a alkyl group. So bromo ethane. So this is the aliphatic. So bromo means again we can solve. Okay. So CH3 CH2 Br. How many carbon atoms are there? Let it start. Whenever the bromine is attached, that carbon is what? First carbon. Because don't start with the left to right. We should start with right to left. First carbon. Where the bromine is attached, and this is your second carbon. How many carbon? 2 carbon. How many hydrogen totally? So here 2 carbon. How many hydrogen totally? Here 2, here 3. So totally 5 hydrogen and 1 halide group. So shortly we can say C2H5Br. Ethyl bromide is what? C2H5Br. Okay. So this is one of the example of a haloalkane. Now you can ask Miss whether you are taken only ethyl bromide. I take methyl bromide. You can take methyl bromide also, no problem. CH3Br. Shall I take propyl bromide? You can take propyl bromide. CH3, CH2, CH2Br. Okay. Depending upon that, whatever may be the reactant, that product only you should ask. Okay. So first, just I am considering what? Ethyl bromide. Okay. Let it add potassium hydroxide. Add what? Potassium hydroxide. Now I have taken what? Reactant. One reactant is ethyl bromide. Another reactant is what? Potassium hydroxide. Now you look the both reactant. Okay? So in the first, bromine is a nucleophile. Miss, I don't know miss how to find out nucleophile here, miss. You know already. C and Br. Whenever more electronegative element is present, okay, now what happened? The electron pair, the bond pair, that should be shifted towards this what? Br. Okay, and Br is assumed as Br minus. Br minus. Now what happened? This is a Br minus means this fully what taken? CH3, CH2 plus. Here, students, you catch this point because whenever the polarization occurs means the compound should be cleaved into two. One is a positive and another one is a negative. So positive we can say electrophile, negative we can say a nucleophile. Okay. In the same way, you go with another reactant, potassium hydroxide. Here also there is a possibility. K plus, because we know this is potassium is what? Metal or non-metal? This is a metal. The metals are what nature? Electropositive nature. So K plus. Here oxygen is what? Electronegative nature. So OH minus. Okay. So now what happened? This is one nucleophile and OH minus also nucleophile. Is it okay? So bromide ion also one nucleophile. Hydroxide ion also one nucleophile because Br minus bromide ion, OH minus hydroxide ion. Okay, so here both are nucleophile, both are having the same strength. But here what happened? Our topic is substitution. Okay, so anyway, one nucleophile is going to be substituted by another nucleophile. This is only called a nucleophilic substitution. Here what happened? In the first molecule, the nucleophile is bromide. In the second reactant molecule, the nucleophile is hydroxide. So we can exchange this OH and then Br. Okay, so is it clear? So this is only called what? Substitution, because both are reacting, both are nucleophile. But anyway, we are in a condition to substitute because we are going to read all the reactions in terms of water substitution. So we can say like this, that is CH3, CH2 as it is. We are replaced by OH. In the same way, K is present as it is, but the K will be replaced by OH will be replaced by Br. So, ethyl bromide converted into containing OH nucleophile, and potassium hydroxide, the nucleophile is what? Here OH minus, but in the product side, the nucleophile is what? Br. This is called a nucleophilic substitution. Then we can see what is the compound name here. We know already, the possible functional group. Okay, so here this is OH. OH means what? Alcohol. Okay, what type of alkyl group is present here? Ethyl. So my name is ethyl alcohol. So what is it? Ethyl alcohol. This is a common name. Ethyl alcohol is a common name. Okay. And let me give IUPAC name. If you want, you can give IUPAC name also. The IUPAC name is ethanol because 2 carbon ethane and the possible functional group is what? Here OH hydroxy. So I can give a OL as a. Okay. So the common name for a compound is ethyl alcohol and the IUPAC name is ethanol. Okay. So the first reaction with the KOH, what we have done is just substituting one nucleophile by another. Is it okay? So this is called what? Nucleophilic substitution. Okay, next we are going to see the second reaction. Okay, second is reaction with the moist. Moist means the water condition because we have to apply with water. The reaction with water. Moist silver oxide. Silver is Ag. And here oxygen, the valency of oxygen is 2 because silver is Ag plus. Oxygen is 2 minus. When we crisscross, we will get a valency Ag. Okay, the valency of oxygen should be at the base of a silver 2. And next, oxygen, the valency of silver is 1. Here only plus 1. So 1 no need to put. So that's why what is the formula for silver oxide? Ag2O. Okay. So reaction with the moist silver oxide. First of all, moist condition we should write the equation. Silver oxide reacts with the water. Okay, reacts with the water. When silver oxide reacts with water, it takes a proton and it gives silver hydroxide AgOH. In order to balance, I'll put 2 here. Then only silver as Ag2, here 2 Ag, here 2, here 2 Ag. Hydrogen is here 2 hydrogen. Okay, and 2 here 2 oxygen. So 2 oxygen. So already it is balanced. Okay, so first we should write the reaction how the silver oxide reacts with the water. Okay, and our product is silver hydroxide. So what is our product? Silver hydroxide. Okay. So now this reactant molecule one day going to be react with the what? Haloalkane. So I am going to take a haloalkane is one CH3. You can take whatever may be the haloalkane. CH3, CH2, Br. So what is the name? You know what is the name of this compound? Ethyl bromide. Ethyl bromide is one. What name? Common name. Okay, or bromoethane. And silver hydroxide. What you are going to add as a second reactant molecule? Silver hydroxide. Okay. So under in what category we are taking this kind of reaction? Under what category? Nucleophilic substitution. Have you find the nucleophile here in this reaction? Okay, good. So Br is a one nucleophile. Is it okay? And OH minus is another nucleophile because Ag is what? Metal, electropositive. OH minus. So here because of the polarity, okay, Br is getting what? Br minus, and this C is getting what? Plus. Okay. So now what happened? This is Br is one nucleophile. OH minus is another nucleophile. Now what is our aim? So we have to substitute one nucleophile by another nucleophile. Okay. And what is your product? You write as it is CH3, CH2, CH3, CH2. And one Br replaced by a one nucleophile OH. Okay. And same way, another product Ag. Okay. What the nucleophile added is Br. Ag, Br. Okay. So now CH3, CH2, OH. The product name is one. Here also we are going to get what? One type of alcohol, ethyl alcohol. And AgBr. AgBr is what? Silver bromide. Silver bromide. Miss, I don't want the Br is here. Shall I replace with a chlorine? Suppose because CH, if you take CH3, Cl, you take CH3, Cl. Ag, OH. Because sometimes they may change it. So then possible we'll get a product CH3OH plus AgCl. Okay, now this is methyl. Methyl, one carbon alkyl group, methyl, followed by this OH. So alcohol. Okay, methyl alcohol. And the side product replacement, silver chloride. What is silver chloride? So that's all. The second reaction, how it is reacts with the moist silver oxide. You people are thinking by seeing the thing, okay, moist silver oxide. Shall I take CH3, CH2, Bra plus Ag2O? If you write like that, that is entirely wrong. And in the book, this equation is not given. Okay, you should kindly note down this. First, you should write that reaction. What is the meaning of moist silver oxide? First, find out the reactant molecule. Then only the silver mention moist silver oxide. Writing the reaction, it is not possible impossible to balance. So that's why I told you. So first you write the conversion which is react with the water molecule, then you go straight away go with the haloalkane. Whatever may be the haloalkane, you add a silver hydroxide, you get a pouch. The second reaction, just we have seen water, silver hydroxide. Okay, moist silver oxide or otherwise. Third reaction, that is third reaction. Okay, how it reacts with ammonia? Reaction with NH3. You know, ammonia is water, NH3. Okay, so now first you take any haloalkane. Okay, so let it take, for example, I will take a CH3, CH2, Br, CH3, CH2, Br. Okay, so ethyl bromide. So in that ethyl bromide, I can add ammonia. Okay. So whenever if you add ammonia into the one more reactant molecule, generally we can call it as the process name as ammonolysis. Because sometimes they may ask, write a short note on ammonolysis. Then we don't know what is called the ammonolysis. That's why I am giving ammonolysis. Okay. So ammonolysis is nothing but reaction with the ammonia. Okay. So first haloalkane need to add a ammonia. Is it clear? Add a ammonia. Okay. Now we know this is nucleophilic substitution. Yes. This is nucleophilic substitution. Here no problem in haloalkane. Br minus C plus. But when you take ammonia, the ammonia you should split like this. H NH2. Here H plus NH2 minus like this. Okay. Now what happened? This Br minus and the NH2 can be replaceable because this is only nucleophile where you get a nucleophilic substitution. So both can be substituted. This under the what reaction? Substitution reaction. One replaced by another. Then you will get a product like this: CH3, CH2 bond. A Br can be replaced by a NH2. Okay, and in the same way, okay. So here the Br will be added with the H. Okay, will be added with the H. So we'll get a side product HBr. What is the side product? HBr. Okay. Now CH3, CH2, Br converted. That is ethyl bromide is going to be converted into ethyl amine. This why is amine? You know, you should know that whenever I am writing the compound based on the functional group. Here the functional group is what? NH2. So what type of alkyl group this is? Ethyl. So you better understood ethyl followed by a amine. Okay, it is suffix name. You should add a amine. So then we will get a ethylamine. And we know this is hydrogen. Hydrogen bromide. Okay. So if you take ethyl bromide reacts with the ammonia, you will get a ethylamine by the reaction of a nucleophilic substitution of one nucleophile by another. So then you can understand this is comes under a type of what? Nucleophilic substitution reaction. Okay. So this is the first reaction where I put only one molecule of a haloalkane. Okay, one molecule of haloalkane only I put, so I will get a product only one molecule. Suppose instead of this one, okay, if I take excess haloalkane, okay, if I take a excess haloalkanes, what happens? Okay. If you take excess haloalkanes. Now, you take the first product. What is your first product? Ethylamine. So, let it take ethylamine as this. CH3, CH2, NH2. Okay, you take the ethylamine. Reacts with one more molecule of a aldehyde. Suppose second molecule I am going to take like this. CH3, CH2, Br. Okay, we know this is your first product. Okay, this is your first product. I'm going to add a second molecule. I'm not talking about a first molecule. Second molecule of a aldehyde. Okay, now what happens? Here also there will be substitution. We know here NH2. Okay, here hydrogen and then Br will be eliminated as a HBr. Then CH3, CH2. Here one ethyl group. In the reactant molecule also, here CH3, CH2. Okay. So this two ethyl group coupled, I can write like this. CH3 combined, I can write like this. CH3, CH2. How many times? 2 times. So base 2 means the molecule should be present 2 times by the elimination of a HBr. Okay, here I eliminated one HN, here one HN, one Br. So remaining is one NH. So I can write NH. What is the side product? HBr. It's a side product HBr. Okay. So now you take this compound, and what is the name of this compound means? How will you find out? Already we know if NH2 present means amine, but here instead of NH2 NH. Okay, this is a secondary amine, not a primary amine. If you get primary amine, you will get like this NH2. Secondary amine means the nitrogen should contain how many hydrogen? Only one hydrogen. So the name is diethyl. Why diethyl? Ethyl group. CH3, CH2 is what? Ethyl group. In that ethyl, how many ethyl groups are present? 2 ethyl groups. So that's why the prefix di should be introduced. Diethyl amine. What is the name? Diethyl amine. And we know already this is hydrogen bromide as a side product. Okay. Next, in the same product, this is second product we know. In that second product, if I add one more haloalkane, CH3, CH2, Br, what happens? If I add one more haloalkane, because totally first one taken, one more added. Now I am going to add how many haloalkane molecule means it's the third haloalkane molecule I have added. So now what happens? Okay, you take this is a reactant. Okay, the reactant is what? Diethylamine. In that diethylamine, one more ethyl bromide I have added. Now what is the reaction? Okay, here this hydrogen and Br eliminated. Okay, this hydrogen and Br should be eliminated. Now what is remaining? Already 2 ethyl group. Now this is also ethyl group. How many totally? How many ethyl groups? 3. So I can write CH3, CH2. How many ethyl group? 3. Okay, how many ethyl group? 3 ethyl group. Okay, now what is remaining? Don't left as it is. Go with the reactant molecule. One nitrogen is remaining. So nitrogen. Okay, and same the side product HBr. That is remaining HBr. Okay, so now if you take the product, okay, we take the product. CH3, CH2 3 times. This is triethyl. We know 3 times ethyl group. That's why triethylamine. This previously you say that is a secondary amine. Secondary amine means nitrogen carries how many hydrogen? Only one. This is a tertiary amine. So nitrogen does not contain any hydrogen. The nitrogen is left free. That's why this is tertiary amine. Okay. So next, how many haloalkanes molecule we have added? Till 3. There is one more chance. If I add one more haloalkane, if I add one more haloalkane, what happens? Okay, so one more haloalkane. Okay, CH3, CH2, Br. So you take this. Now I am going to add this as a product. Now already 3. One ethyl group is present. So I can write like this. CH3, CH2. How many times? 4 times. 4 times. And N is here. N is without hydrogen. So that's why N plus. Why I am giving like this means Br minus. There is a charge separation. This is called a quaternary salt. Generally, quaternary salt. Quaternary salt means we should indicate charge separation only, because one positive, one negative we should write. That's why I am writing N plus and Br minus. Okay, this is quaternary salt. So, trimethyl ammonium bromide as a specific name. Tetra ethyl ammonium. So ethyl group is how many times? 4 times. That's why tetra ethyl. For N ammonium bromide. So this is a specific name of the compound. General name quaternary salt. Specific name tetra ethyl ammonium bromide. Okay. Now one molecule means only called a substitution reaction. When we add excess molecule of haloalkane, we will get diethylamine, triethylamine, tetraethyl ammonium bromide as a product. Okay, so in the examination point, if they ask how haloalkane reacts with the ammonia means you left it one product. If they specifically mention that what happened with the excess haloalkane molecule, you write all the reaction, comes finally with the tetraethyl ammonium bromide. Then only the equation will be satisfied. Okay, and one word also. So if they are asking how the haloalkane, that is CH3, CH2Br, ethyl bromide reacts with the ammonia, what is the product formed? Of course, your product is ethylamine. Okay, so it is clear. So generally, you took only substitution reaction. Into the substitution, we have discussed how many points? Only 3 points. First reaction with the KOH, second reaction with the moist silver oxide, and third one reaction with what? Ammonia. Okay. So next we are going to discuss so far we discussed about a nucleophile. I said what is nucleophile? Generally we are talking about a nucleophile Br. Okay, this is a nucleophile Br minus. Okay. Now this nucleophile is going to be added and substituted like that only. So far we discussed the reaction. But next reaction we are going with same nucleophile only. But I am going to take a different nucleophile and those reactions also different. Okay. So in that next I am going to introduce antidentate nucleophile. Okay, previously we used what? Only nucleophile. But now I am going to use one more word that is called an ampidentate nucleophile. What is the meaning of this ampidentate? A nucleophile is going to be attached in different way. Okay, nucleophile attached in different way. What different way means? It differs in the attachment of atoms. Differs in the attachment of atoms. For example, if I take ampidentate nucleophile example, Cn minus. Okay, so usually the Cn minus, we know this is a cyanide ion. The name of the nucleophile is what? Cyanide ion. In that cyanide ion, if I add this into any reactant, if this reactant molecule, it can attach in two ways. Okay, one thing C will be attached, another way N will be attached. What are the C and N? These two different atoms. Okay, so if C has attached one product, N has attached one product. This is called an ampidentate ligon. A ligon can be attached in different way. What difference means? Atoms only differ. Okay, so like one example. Suppose I am going to give nitrite, because that's why the two ligands we are going to discuss. Nitrite ion. If I take a nitrate ion, okay, see there are two possibilities. Nitrogen can be attached, oxygen can be attached. Okay, so let us see the reaction, how this atom should be attached in different way. So first reaction, okay, reaction with the potassium cyanide. This is called what? Under what topic we are reading? Under nucleophilic substitution. Always you should keep it in your mind. First we are seeing only nucleophilic substitution. So first reaction, we have taken the nucleophile, only one atom attached. Okay, it has a possibility only one atom attached. Now we are going to into the same type of nucleophile, ampidentate nucleophile. Into that ampidentate nucleophile, where the atoms can be attached in different ways. If I take cyanide, in one reaction C will be attached, in another reaction N will be attached. Like that. Okay, so reaction with the KC. You take haloalkane, CH3, CH2, Br. Okay, CH3, CH2, Br. What is this? Ethyl bromide. In that ethyl bromide, add a potassium cyanide. We know already. Yes, while I am writing the reactant molecule itself, you can find the product, because almost we know Br is a one nucleophile, Cn is a one nucleophile. Definitely it is going to be substituted. Yes, good. But first reaction possibility is correct, because C. I am going to write C attachment nucleophile. Okay. So then both can be replaced like this. You get the product CH3, CH2, Cn. Okay, and this K and Br should be added. So KBr as a side product. Potassium bromide. What is that? Potassium bromide. Okay. Now we know already this is ethyl bromide, one reactant molecule. What is KCl? Potassium cyanide. Potassium cyanide. Okay. And what is this product? This is cyanide ion. Cyanide nucleophile. Ethyl group CH3, CH2, ethyl. So that name is ethyl cyanide. Common name. Ethyl cyanide is a common name. What is the IUPAC name? IUPAC name cyano because the nucleophiles end with the O. Cyano ethane. 2 carbon atoms, so that's why ethane. Okay, so here the nucleophile, it is going to be substituted. While it is substituting, this carbon should be attached. If it is carbon is attached, we can name it as a cyanide. Okay, and one more, the second reaction I am going to write that N should be attached. N atom should be attached. Okay, you take same ethyl bromide. Okay, you add a potassium cyanide. Potassium cyanide as a reactant, that is okay. But even though it is nucleophilic substitution, instead of this carbon, because it is totally nucleophile, instead of this carbon, the nitrogen should be attached. So I can write CH3, CH2, NC. Can you make a difference between the first reaction and the second reaction? In the first reaction, carbon atom is attached. In the second reaction, nitrogen atom is attached. That's why cyanide is an antidentate ligand. It is not possible with all ligand, all nucleophile. Okay, if the antidentate nucleophile only, it has a tendency of attracting in different way. Different atoms should be added. Okay, so now this makes a difference. And same way, the side product is KBr. Okay, now C attached, we can talk about ethyl cyanide is a name. While N attached means the name is ethyl, we should say ethyl isocyanide. What is the name? Ethyl isocyanide. Isocyanide. Because C is attached cyanide, N is attached isocyanide. This makes only difference. Okay. So even though potassium cyanide as a reactant molecule, it reacts in two different ways, and we are getting different product. One product is cyanide, and another product is what? Isocyanide. In the same way, if you take a nitrate also, okay, it's nitrite reaction. Okay, reaction with the silver nitride. You know AgNO2, this is what? Silver nitrite. Okay, silver nitrite. You take CH3, CH2, Br. This is haloalkane, ethyl bromide. Add silver nitrate. Okay. You know, in haloalkane, Br is a nucleophile. In silver nitrate, NO2 is a nucleophile. But I said NO2, nitrite is an antidentate nucleophile. Where in that nitrite, nitrogen can be possible. One possible, nitrogen can be attached. Another possible, oxygen can be attached. Okay. The first reaction I am going to write, the nitrogen should be attached. Here, both nucleophile will be substituted. Okay, one nucleophile will be substituted by another nucleophile. Possibility CH3, CH2, NO2. Is understood? Okay, even though it is antidentate ligand, one possible product just linked to what atom? Nitrogen atom. Okay, and next the same product is silver is remaining, and one more nucleophile is what? Br. So is it okay? Now, how can you give a product name? Because each product different function group will be there. Here when you note NO2. Okay, NO2. You better just learn how to give a name based on the functional. You know all the functional group only, it is possible to get a name. Okay, so here nitro. Okay, so nitro as a functional group. Okay, prefix. You can use a nitro as a prefix. How many carbon atom? 2 carbon atom. So 2 carbon atom means nitroethane. What's the name? Nitroethane. Okay, and AgBr, silver bromide. Okay, so ampidente ligand NO2. Okay, NO2 minus. Here, just I have added only nitro group. First type is bromide. Okay, and next same reaction. Okay, CH3, CH2, Br. Instead of that, if I use KNO2, KNO2. So this name as potassium nitrite. While I am writing NO2, NO3, better clear. NO3 means nitrate, NO2 means nitrite. Okay. So here the attachment is different. Okay. See what happened? Instead of nitrogen, oxygen should be added. Okay. So in the NO2 group, okay, I can write O double bond NO. It is also NO2. O double bond NO. Okay. Here what happened? Then oxygen only I am going to be attached with the nucleophile. So here the nucleophile is what? Here also NO2 minus, but ONO. Just I am writing splitting of a compound. So next the product is CH3, CH2. Okay. So here the first reaction, just I have added nitrogen atom. In the second reaction, I am going to link the oxygen. So O double bond NO. So that is also NO2, but here I have linked what? Oxygen atom. So based on that, the name also changed. This name as ethyl nitrite. Nitrite. N attached means nitro. O attached means nitrite. Nitrite. But the same side product, silver. Instead of silver, you'll get a potassium when we take instead of that just we are taking potassium, so KBr. So potassium bromide, okay, as a product. Now we are seeing with the ampidente ligand. In ampidente ligand, the attachment of a nucleophile is different. Okay, so the nucleophile is same, Cn minus, Cn minus, but in the Cn minus, One carbon should be attached. In the second reaction is what? Nitrogen should be attached. Same way, here nitrite as an antidentate we got. In the first reaction, nitrogen will be attached. In the second reaction, oxygen will be attached. So this is called a antidentate nucleophile reaction. Okay, and next we are going to see the reaction. How it is reacts with the reaction with the sodium, hydrogen, sulfide, NaSHS, sodium, hydrogen, sulfide, sodium, hydrogen, sulfide. Okay, so first let us take one haloalkane CH3, CH2, Br. Okay. Now I am going to add a sodium hydrogen sulfide as a one reactant molecule NaSH. Br is a one nucleophile here. SH is a nucleophile. This is a positive and this is a negative. Okay. Now what happened? Both will be effective and both will be reactive and both can be substituted and we are getting a new product CH3, CH2, SH plus NaBr. Okay. Now here this is ethane. 2 carbon ethane. Whenever S means thiol, SH means thiol. We know already. Compound OH means hydroxy or alcohol. This is alcohol. Instead of this O, if I replace SH means this is what a thiol. So like that, give a name ethane thiol. Okay, and this is side product name sodium bromide. Sodium bromide. Okay, this is also one of the nucleophilic substitution reaction where haloalkane is going to react with what? Sodium hydrogen sulfide. Okay, and one more reaction. Williamson ether synthesis. Williamson ether synthesis. Okay. So actually, while I am writing this Williamson ether synthesis, the reaction name itself consisting of a ether. Okay, and you should know that this is a preparation of a ether. One clue, that is preparation of a ether. So anyway, whatever may be the reactant molecule, you keep it in your mind. We are going to prepare a ether. Okay. So if I take the haloalkane CH3, CH2, Br. Okay, react with the sodium alkoxide. If I take this compound, sodium, this is sodium ethoxide. Sodium ethoxide. Okay, now we know that here it is a nucleophile. Okay, Br. Here it is a nucleophile Br. Okay, but this compound sodium ethoxide I can split like this: Na plus OCH2CH3. That is minus part. This is only a nucleophile. This is a nucleophile. So what reaction we have seen under nucleophilic substitution? So one nucleophile is going to be substituted with another nucleophile. So probably we are going to get a product like this. That is CH3CH2 from one reactant molecule left and this bond, okay, added with the O and remaining in the second molecule also CH3, CH2 is remaining. Okay. And the side product is NaBr, sodium bromide. Okay. So now you see, how will you find out this is ether? In whatever may be the organic compound, if oxygen is linked, okay, if the oxygen is linked between the two alkyl group, then we can call it as what? This is a ether. Okay. Now, what is the name of this ether? Diethyl. Because why I am using di prefix means there are two ethyl group. Okay. So diethyl ether as product. Okay. So next, this is sodium bromide. Sodium bromide. Now, this Williamson ether synthesis, even though we have prepared ether, this comes under the reaction nucleophilic substitution, where one nucleophile Br minus is substituted by another nucleophile C2H5O minus. You can write like this also. So no problem. C2H5O minus. This is called, suppose, what is this name of the nucleophile gas? This is ethoxide. What is ethoxide ion? This is a nucleophile. Okay. So students, till we have discussed today, we have started with only the chemical properties of a haloalkane. First, just we have started with what is haloalkane based on reactivity, and I have given the idea about what is nucleophile and what is called nucleophilic substitution. And next we have seen only one, the nucleophile should be added. That area we have discussed only three reactions: reaction with the KOH, reaction with the moist silver oxide, and reaction with the ammonia. Okay, these three reactions, just we have used only the nucleophile. The attachment is in only one way. And next we are talking about an antidentate ligan. Antidentate ligan means a ligan can be coordinated in different way. Coordinating means the atom attachment can be different. So that under that topic, just we have discussed about reaction with KCN, reaction with the silver nitride, reaction with the sodium hydrogen sulfide, and finally we have discussed about a Williamson ether synthesis. Okay, this is how the chemical properties of a haloalkane and just only substitution reaction. Okay, so we discussed only today substitution reaction, that is nucleophilic substitution. Students, if you have any doubt, you can ask. Okay, you can ask. Otherwise, whatever maybe you share with me.